Greetings and welcome to my channel. My name is John Gabriel. So today I'm going to focus a little bit more on a topic I raised in a previous issue, that of the so-called constant of integration, because I've received quite a big response on that, and so I'm going to address it now with a little chat with ChatGPT 3.5. So I'll start off by asking it to explain why it's added, and say that if my primitive function is x squared and I integrate to x, I get x squared and there's no constant. So ChatGPT says it's added because when you differentiate a constant, it becomes 0. Well, first of all, I'm not differentiating anything. I'm integrating. Okay. And then it says when you integrate, you blah, blah, blah. And then it says the constant accounts for the family of functions. Well, I don't really care for the family of functions. I just care for the general derivative. Okay. And if the constant is going to appear, is going to disappear when I differentiate it, why add it in the first place? It doesn't make any logical sense, does it? I mean, ask yourself. So here you are, you're saying integrate 2x with respect to dx, and you're saying it's equal to x squared plus c. There's no reason to add this. Okay. Yes, we know that c could be a lot of values, but does c represent all those values? No, it doesn't. It doesn't represent any of them. It's just a symbol. We don't know how many constants are there. There could be an innumerable number of constants. Besides, so many mainstream academics go on about how 0 is a number. Well, if I wrote plus 0, that would be the same as writing x squared, wouldn't it? So can you see how petty and stupid mainstream academics are, how incorrigibly stupid they are? Okay, let's continue. So it says, well, I ask it again. I put another prompt to it. I say it is an obvious fact that many functions, when differentiated, will yield the same result. And if I'm integrating, I do not care about differentiating, so there's no need to add a constant. So then again, ChatGPT, as per its pre-training, says that there are infinitely many functions with the same derivative. Yes, there are, but so what? I mean, it's stating the obvious, isn't it? It's an obvious fact, and it doesn't play any part in the solution. It doesn't make the solution any more correct. And then, of course, I try to coax GPT by telling it that it's unnecessary unless you have a boundary value problem, and you're going to be using an initial value, an initial condition. So again, ChatGPT tries to remain neutral and says, and basically restates my viewpoint and says, yep, but that's how you think, but that's how the mainstream thinks. So I tell ChatGPT that I can omit it in all contexts, because the fact that it can be so many other things does not make it more correct than without the constant. After all, the derivative of 0 is 0. Okay, so we have a little back and forth here, and then still trying to get ChatGPT to see reason, and I'm saying that it is unnecessary to write the constant under any circumstances. So I get to the point, stop bashing about the bush. I say it does not make my result wrong or incomplete in any way. Okay, it doesn't, writing a constant. And it's just absurd to assume that writing a simple symbol constant captures all functions. It's a silly form of self-deception, in my opinion. And then, of course, I, brutally asked GPT, well, can you understand the validity of my reasoning? And that adding a constant is moot. And then it comes up with this response here. It says your reasoning challenges the necessity of adding a constant. The traditional approach includes the constant for generality. I don't know how including the constant for generality makes it any more correct than without the constant. So and then finally it says, your point is well taken. In many practical situations, only one member of the family of antiderivatives is relevant. Okay, so, and then I said if you were able to make a decision on its use, because GPT tries to keep a neutral stance, would you, in the light of our discussion, choose to write a vacuous symbol that represents nothing solid, or would you simply omit the constant unless you have something like a boundary value problem? And it says, given the context, it seems reasonable to consider omitting the context. Okay. And then it says it aligns with traditional approaches, but not my mathematical approach. So then I ask it, what is my mathematical approach? And it says, it involves challenging the conventional practice of including a constant. And then I asked it, is there ever any knowledge that is beyond further investigation? Is not all knowledge subject to revision and correction? And then it responds by agreeing, basically. It says, yes, it is. And then it says the scientific method and pursuit of understanding dictate that our knowledge is always provisional. But here's my response. And yet the majority of mainstream calculus academics claim that the formulation is rigorous and established knowledge. And watch how, again, ChatGPT tries to cover its bases. It says, is a common viewpoint with mainstream academia. So as far as they're concerned, it's rigorous and established. And then it starts delving into the nonsense of axioms here. So what I want to tell you here is that it really doesn't matter whether you write this or you don't write this. Okay, there's no difference. Unless, of course, you're trying to find an exact solution where you have, you have x is k and f of k is v or something. All right? That's pretty much it. My name is John Gabriel. This is a new calculus channel. Until next time, goodbye.